Okay. You're welcome once again. We are going to be looking at the 2024 chemistry JAMB question. We will try um to provide answers to the questions and explain the reason why we chose the answer. So on your own part, what I expect you to do is to um make sure that you attempt the question. I may not really wait for you to, wait for all of you to drop your answers. But when you attempt the question, try to put your answer in the comment section, and also look at it in comparison to whatever answer that I've given and the explanation that I've provided. I believe this will help you a great deal. So without much ado, let's jump into the um the questions proper. The first question says, at a given temperature and pressure, gas X diffuse twice as fast as gas Y. It follows that gas Y is 2 times as heavy as gas X. Gas Y is 4 times as heavy as gas X. Gas Y is monoatomic. Gas X is diatomic. So we have the options from A to D. So if you look at it closely, we discover and you do the right thing regard interpreting the question right. You have your answer to be B, which is gas Y is 4 times as heavy as gas X. Now the explanation is this. According to Ram's law of diffusion, if Rx equals to 2Ry, then Rx, rate of diffusion of X, that's what I mean by Rx, and rate of diffusion divided by rate of diffusion of Y will be what? The relative molecular mass of Y divided by the relative molecular mass of X square root. So if Rx over Ry equals to 2, that means the square root of My divided by mx will be equal to 4. It means that y is 4 times heavier than gas X. The number of molecules of helium gas contained in 11.5 gram of gas is it 1.73 times 10 raised to the power 23? Is it 1.73 times 10 raised to the power 22? 1.73 times 10 raised to the power 24? Or 1.73 times 10 raised to the power 21? Now, if you take out time to do the calculation properly, considering that you first convert to mole, after that, you multiply by the Avogadro's constant, 6.02 times 10 raised to the power 23. If you do this right, you will end up having the answer to be C. And this is the explanation. The first thing is that the molar mass of helium is 4 grams per mole. So therefore, the number of moles will be mass divided by the molar mass. So the number of moles is 2.875 mole. Now, the number of molecules, like I said earlier, will be what? The mole multiplied by the Avogadro constant, and that approximately was 1.73 times 10 raised to power 24. Okay. The constituents of Hanico are aluminum, nickel, and is it A, magnesium, B, cobalt, C, manganese, D, copper. So if you look at it closely, you discover that the right answer to this is B. That's cobalt. Manico is an alloy made from aluminum, nickel, and cobalt. It is known for its magnetic properties. Okay. The next one says that silver and gold are metals found as free, uncombined elements in the Earth's crust, which makes them to be referred to as A, corrosive metals, B, reactive metals, C, natural metals, D, noble metals. So the answer to these is actually D. They are referred to as noble metals. And noble metals like silver and gold are chemically stable and do not easily react or corrode. Hence, they exist freely in nature. Okay. In the extraction of aluminium, the silica impurity is removed by is it true? Is it by electrolysis, filtration, reaction with H2SO4, precipitation? So the right answer to this is actually D. And the reason why we are choosing option D is because during purification of bauxite, um, Al2O3.2H2, silica is removed by precipitation after forming a soluble sodium silicate in the Bayer process, followed by reprecipitation. So the answer to these is D, precipitation. The next one says that when calcium ethinide is decomposed by water, the gas produces carbon 2 oxide, B, hydrogen, C, C2H2, that's ethane, and then CH4, that's methane, or methane. Okay, the correct answer to this one is C2H2, ethane. Um, if you look at the equation of the reaction, you can see clearly the formation of ethane when calcium ethinide is decomposed by water. So the constituent of petroleum fraction used in surfacing roads is it A, petrol, B, diesel, C, lubricating oil, or D, bitumen? So the one that we use, the constituent of petroleum that we use for surfacing road is actually D, bitumen. Bitumen is the heaviest fraction obtained from the bottom of the fractional distillation column and is used for road surfacing and roofing due to a sticky, viscous nature, or viscous rather, not vicious, viscous nature. Okay. Number 8 says that during the fractional distillation of crude oil, the fraction that distills at 200 to 250 degrees Celsius is A, bitumen, B, diesel, C, kerosene, D, petroleum. So when we look at this one closely, the fraction that distills is diesel, at 200 to 250 degrees Celsius is diesel. And fractional distillation temperature for petrol, it will distill out at between 40 to 100 degrees Celsius. Kerosene between 150 to 200 degrees Celsius. Diesel 200 to 250 degrees Celsius. Then bitumen greater than 350 degrees Celsius, which is forms the residue now. Okay. The next one says that the liquid hydrocarbon obtained from fractional distillation of coal tar that is used in the pharmaceutical industry is A, xylene, B, benzene, C, hexane, and D, toluene. The right answer to this one is actually B, benzene. And the reason why we chose benzene is because benzene is widely used as a precursor in drug synthesis and in the production of many chemicals. It is obtained from coal tar during fractional distillation. The next one says that an organic compound contains 53.1% carbon, 6.2% hydrogen, and 12.4% nitrogen, and 28.3% oxygen. What is the molecular formula if vapor density equals to 56.5? And then we are given the relative atomic masses to be 12 for carbon, 1 for hydrogen, 14 for nitrogen, and 16 for oxygen. Now, when you look at a rundown of all the options that we have there, the most suitable one or the most appropriate will be option A, which is C5H7NO2. And how did we come about this? We work it out. Now, looking for the first the empirical formula. So we'll do a step-by-step solution. So when you assume 100-gram sample, it means that you have your carbon to be 53.1 gram. The 53.1 gram will be divided by the relative atomic mass of carbon, which is 12. So you end up having a 4.2 mole, a 4.2 mole. For hydrogen, it will be 6.2 gram divided by 1. So you have a 6.2 mole. And then for nitrogen, it will be 12.4 divided by 14, and oxygen will be 28.3 divided by 16. So you have their mole, you will get out their mole. After that, we divide by the smallest mole. And the smallest mole in this regard is 0.886. Now, when you look at it critically, when you divide, all that you have by the smallest mole, you have carbon to be having 5, hydrogen to have 7, and then nitrogen will have 1, and oxygen will have approximately 2. So the empirical formula basically will be what? A C5H7NO2. C5H7NO2. We know that the empirical formula mass from what we have gotten there will be what? 5 multiplied by 12. That's carbon, which is 5 multiplied by 12, which is the relative atomic mass of carbon. And then 7 multiplied by 1, 14 multiplied by 14 plus 2 multiplied by 16, and it goes on like that. When we do the calculation appropriately, we'll end up having um, um, a molar mass of about 113. But don't forget that vapor density, sorry, don't forget that molecular mass equals to 2 of the vapor density. That's 2 multiplied by the vapor density. So if we have the molecular, what's it called? The molecular formula um, of the distance to be like 50, sorry. So if we have the vapor density, pardon me, if you have the vapor density to be 56.5, so that would be molecular mass would be what? 2 times 56.5. And don't forget that the molecular mass has calculated is what? 113. So the empirical formula equals to the molecular formula, which will be equal to what? C5H7NO2. Okay. The empirical formula of an organic liquid hydrocarbon is XY. If the relative molar masses of X and Y are 72 and 6 respectively, its vapor density is likely to be A, 33, B, 66, C, 39, D, 78. Now, when you look at this and we apply the appropriate law that we are supposed to apply, we'll have this as our formula, as our answer option C, which is 39. How did we arrive at this? Vapor density equals to molar mass divided by 2. Now, given the empirical formula to be XY, empirical mass will be what? 72 multiplied by X plus 6 Y, and that will cost to 78. Therefore, molar mass is 78. Hence, the vapor density will be equal to 78 divided by 2, and that will give us 39. That will give us 39. So, moving on to the next one, Burette test is a chemical test used for detecting the presence of A, carbohydrates, B, proteins, C, amines, D, alkaloids. We use Burette test to determine the presence of proteins, actually. So the answer is B. And the Burette test detects peptide bonds which are present in proteins. A purple color indicates a positive result. Okay. 13 says a gas, when mixed with oxygen, it produces a very hot and easily controllable flame. What is the name of the flame and where is it used? Is it acetylene flame? Is it used in the miner's lamp? Is it called oxyethylene flame? Is it used in the hunter's lamp? Is it called oxyethylene flame? Is it used in the miner's lab? Is it called oxyacetylene flame? Cutting? Is it used for cutting and welding metal? So the right answer to this is actually D, oxyacetylene flame, and it's used in cutting and welding metal. So oxyacetylene flame is used in cutting and welding due to its high temperature, greater than 3,500 degrees Celsius. So it is a combination of oxygen and ethylene. So we call it acetylene. Okay, a combination of oxygen and ethane, which is also referred to as acetylene. Okay, so the next one says, oh, we've given the explanation already. Okay, let's just do this now. The next one says that the number of geometrical isomers butene are of butene are, is it two? Is it three? Is it five? Is it four? So the answer to here is two. Butene has two isomers with CC double bond, carbon-carbon double bond. And we have the cis but 2 in and the trans but 2 in. These are the only geometrical isomer possible. But one in cannot show geometrical isomerism due to one end of the double bond being bonded to two hydrogen atoms. Okay, so that's that for that. The next one says that how many isomers as the organic compound represented by the formula C3H8O. Is it two? Is it three? Is it four or five? So the right option here is actually option two. Option A, which is two. And the reason is because molecular formula with a C3H8O, two isomers are possible. One, it can be propan all, and the second one can be propan two all. Okay. When a few drops of million reagent is added to egg white solution in a test tube, the white precipitate changes to what now? Does it change to orange, or is it brick red, or reddish brown, or blue? So the answer here will be that when we add a few drop of million reagents to egg white solution, the change that we experience is a reddish brown, which is option C. We notice a reddish brown coloration. And this is because million reagents is used to detect the phenolic groups present in tyrosine, an amino acid found in proteins such as egg whites. So a reddish brown coloration confirms the presence of protein. Okay. The next one says that if the solubility of potassium nitrate at 30 degrees Celsius is 3.10 mole per dm cube, a solution containing 303 gram per dm cube of KNO3 is likely to be A, saturated, B, unsaturated, C, supersaturated, D, at saturation point. So the right answer here should be unsaturated as B. Should be unsaturated as B. And the reason is because first, we calculate the um, molar mass of KNO3. And when we do that, we end up having the molar mass to be 39 plus 14 plus 48. That will be 101 gram per mole. Now we calculate the molar concentration, 303 gram per dm cube, when we divide it by 101 gram per mole, because what you're just doing is just like you're calculating the molarity. So molarity equals to concentration in gram per dm cube divided by the molar mass. So you end up having 3.0 mole per dm cube. Since solubility at 30 degrees Celsius is 3.10 mole per dm cube, a solution with a 3.0 mole per dm cube is slightly less than saturation, which should be unsaturated. So that's the answer to that. Okay. 127 grams of sodium chloride was dissolved in 1.0 dm cube of distilled water at 25 degrees Celsius. Determine the solubility in mole per dm cube. We're given the relative atomic mass of sodium to be 23 and that of chlorine to be 35.5. And then we have the options that we have there from option A to D. So when we solve or we'll work it out properly, we end up having these as our answer, option C, which is 2.2. That would be our answer. And the explanation for this is because the molar mass of sodium chloride is 58.5 gram per mole, and solubility equals to 127 gram per dm³ divided by 58.5 gram per mole. And that will give us what? 2.17 mole per dm³, approximately 2.2 mole per dm³. Okay, so that's that for that. So let's look at another one, which is question 19. The quantity of electricity required to deposit 180 grams of silver from a molten silver nitrate is it 1.08 Faraday, 3.30 Faraday, 1.67 Faraday, or 1.80 Faraday? Now, the answer to this is 1.67 Faraday. And how did we arrive at this? Simple calculation. From Faraday's law, we know that 1 mole of silver, 108 grams, requires 1 Faraday of electricity. Now, to deposit 180 grams, it will require us doing 180 grams divided by 108 grams per mole, which is the molar mass of silver. Okay. So if you do that, you end up having 1.67 mole. So therefore, that 1.67 mole will multiply by 1 Faraday, and that will give us 1.67 Faraday. So option C is the right answer. This next one says that what would be the order of the electrolytic cell in an industry intending the production of silver-plated spoon? A, cathode is the spoon, anode is a silver rod, electrolyte is a soluble silver salt. B, cathode is a silver rod, anode is the spoon, electrolyte is a soluble silver salt. C, cathode is the spoon, anode is any rod, and electrolyte is soluble silver salt. D, cathode is any rod, anode is the spoon, electrolyte is a soluble salt. So the right option for this one is actually option A. Cathode is the spoon, anode is a silver rod, and electrolyte is a soluble silver salt. So when you do electroplating, the object to be plated, which is the spoon, is placed at the cathode, and at the anode is a rod of the metal to be deposited, and in this regard, silver. And then the electrolyte must be a solution of the metal salts, e.g., NO3. Okay. So the next one says that the table above shows the formulae of some ions. In which of these compounds is the formula not correct? Is it in aluminium tetraozosulfate 6, calcium triazonitrate 5, iron 3 bromide, or potassium sulfide K2S? Now, when you look at all of these ions critically, you discover that one looks like this compound critically. You look at that one is an outlier, or is the odd one there. And the reason is just based on the position of the subscript that is there. If you look at option C carefully, you have iron and bromine reacting together. There's no way we'll have Fe3Br. It's not possible. So the odd one there, and that is the answer, is iron 3 bromide, Fe3Br, because that is not possible, to occur. Fe3 is iron 3 and Br minus. Now, when there's a cross between the two and an interaction between the two, what you should have ideally should be your Fe, then maybe Br3. But in this case, Fe3, what I'm saying is that Fe3 will require 3 bromine to balance one Fe3 plus. So the correct formula should be what? FeBr3 and not Fe3Br as stated in the question. So that's the odd one out there. Every other one checks out except this one. So the next one says that the pH of 0.001 mole per dm³ of H2SO4 is it 2.7, 3.0, 3.3, or 2.0? The answer to these is 2.7, 2.7. And the solution basically is this. H2SO4 is a strong diprotic acid, meaning it ionizes completely in water. So when you have H2SO4, it ionizes completely in water, and it dissociates into hydrogen ion, two, and so two hydrogen ions, and then the SO4 2 minus ion. So for 0.001 mole per dm cube, the hydrogen ion will be what? 2 multiplied by 0.001, which will be equal to 0.002 mole per dm cube. Now, when we plug this in into pH equals to minus logarithm concentration of hydrogen ion concentration. So that will be minus log 0.002, which will be equal to minus log 2 times 10 raised to the power minus 3. And when you solve properly, you end up having your answer to be 2.7, which is the right answer. The next one says that strong acid can be distinguished from weak acid by any of the following methods, except A, conductivity measurement. A, conductivity measurement. Conductivity measurement. B, the use of litmus paper. C, measurement of pH. And then D, measurement of heat of reaction. Now, when we look at this, we discover that the correct answer is B, the use of litmus paper, the use of litmus paper. Okay, that's the correct answer there. So, the explanation for this is this. When we talk about strong acid, being distinguished from weak acid, um, you discover that with conductivity measurement, strong acid ionizes more. So higher conductivity shows that it's a strong acid. So this can be used. The use of litmus paper, you discover that both strong and weak acid turn blue litmus paper red. It doesn't distinguish strengths. So you cannot use it to distinguish how strong, the strength of the acid. Measurement of pH, strong acid have lower pH. So we can use this to distinguish. Measurement of heat of reaction, strong acid typically release more heat due to full ionization. So this also can be used for as a distinguishing factor. So the odd one out is the use of litmus paper. The chemical formula for potassium hexacyanoferrate 2 is FeCN6 4 minus K3 FeCN6 and FeCN6 or K4CN6. So going by this one, the right answer is actually K4FeCN6. How did we arrive at that? The complex FeCN6 has a charge of 4 minus, and then potassium has a charge of 1 plus 1, when they interact, it means that to balance the charge, 4 potassium will need just 1 FeCN 6 ion. So you end up having what? The 4 in from the hexacyano ferrate being transferred to the potassium, and potassium transferring 1, which is its own oxidation state or number, to the hexacyanoferrate. So it now gives us what? A K4FeCN6. So that is what we'll end up having in that regard. Now, when we look at the next one, it says for a chemical reaction to be spontaneous, delta G must be A, positive, B, negative, C, 0, D, equal to the enthalpy change. Now, for a chemical reaction to be spontaneous, delta G is actually supposed to be negative. So B is the answer, and spontaneity is determined by the Gibbs free energy chain, delta G. If delta G is less than 0, that is negative, reaction is spontaneous. If delta G is greater than 0, that is positive, the reaction is non-spontaneous. If delta G equals to 0, the reaction is at equilibrium, So we must take note of that. Okay. On to the next one, which says how many moles of CO2 are produced when ethanol is burned with 6 grams of oxygen? Is it option A? Is it option B, C, or D? Now, if you carefully solve this, you will end up having the correct answer to be 0.125. 0.125. And how do we go about this? Looking at the balanced combustion equation for ethanol, you have that, and then you have these coefficients, appearing when you balance the equation. So the first step is to calculate the mole of oxygen given. Now, the molar mass of oxygen is 32 gram per mole. The given mass of oxygen is 6 grams. So therefore, the mole of oxygen in this regard will be 6 divided by 32, and that will be 0.1875 mole. Now, step 2 is to use stoichiometry. From the balance equation, 3 moles of oxygen will require what? 2 moles of carbon dioxide. Okay, if that is the case, then it then connotes that from the balance equation that 0.1875 mole of oxygen will translate to 2 over 3 times 0.1875. So, and that will give us the moles of oxygen of carbon dioxide to be 0.125 mole, 0.125 mole. Okay. The next one says that which of these is the most preferred separation technique for the isolation of solutes where the purity of the constituents is of utmost importance? So sieving, distillation, recrystallization, or precipitation. The right answer here is recrystallization, and this is one of the techniques that is used if you want a very pure substance. It is mostly employed even in the pharmaceutical industry too. So recrystallization is very important. And when you look at the other options that we're given, sieving used for particle size separation, not effective for solutes. And another thing again is distillation. It's good for separating liquids based on boiling point. Precipitation is useful for separating insoluble solids from solute solution, not necessarily high purity. And then recrystallization, best method for purifying solid solutes, relies on solubility differences. Okay. The next one says that in the graph above, Y represents what? Now, what does Y represent? Is it the endothermic reaction, B, activation energy, or C, exothermic reaction, D, ionization energy? So Y in this regard represents the activation energy. It represents the activation energy. And if you look at the graph that we were given, you discover that the the graph shows an energy profile of a chemical reaction. The Y value represents the energy difference between the reactants and the peak of the energy barrier, which is the activation energy. Now, activation energy is the minimum amount of energy required to start a chemical reaction. The downward arrow labeled delta H shows that the products have lower energy than the reactant, indicating an exothermic reaction or reaction overall. However, Y specifically refers to the energy barrier, not the enthalpy change. So the correct term is activation energy. Activation energy. The ion represent the ion responsible for permanent hardness in water are sulfate of iron 3 and magnesium 2, sulfate of calcium 2 ion and magnesium 2 ion, sulfate of iron 2 and iron 3 ion, or sulfate of sodium ion and calcium ion. So the answer to these is actually option B. That's the sulfate of Ca2 plus and Mg2 plus. So permanent hardness in water is caused by the presence of soluble calcium ion and magnesium ion salt, particularly their sulfate and chloride, which cannot be removed by boiling. These ions form soluble compounds in water and require chemical treatment for removal, e.g. by using washing soda or ion exchange resins. Okay. One of the following is not a water pollutant. One of the following is not a water pollutant. Inorganic fertilizers, warm water effluents, oxygen gas, biodegradable waste. The only option that is not a water pollutant there is oxygen. Oxygen gas is not. Oxygen gas is essential for aquatic life and is not a pollutant. On the contrary, it helps with the breakdown of organic matter by aerobic bacteria. The other ones, when they are introduced, they are all organic pollutants. Inorganic fertilizers introduce nitrogen and phosphate, leading to eutrophication. Warm water effluent reduces or effluent reduces dissolved oxygen in water, disrupting aquatic ecosystem. And then biodegradable waste can lead to oxygen depletion during decomposition. Okay. So 31 says that what is the effect of increased pressure on the equilibrium position for that particular equation there? Is it A, the equilibrium is shifted to the left, the equilibrium is shifted to the right, there is no effect, more hydrogen gas is produced? The right answer there is that there is no effect. Now, did we choose this option? Now, when pressure changes, or pressure changes affect only gaseous species. In the given reaction, the number of gaseous molecule on both sides is the same. The left, we have 1 mole of hydrogen gas. On the right, we have 1 mole of water gas. Since there is no net change in gas moles, increasing pressure has no effect on equilibrium. Okay. What method is suitable for the separation of gases present in air? Is it A? Is it B? Is it C or D? The best method for separation of gases in air is actually B, fractional distillation of liquid air. And that's a B. And air is liquefied under high pressure and low temperature, then separated by fractional distillation based on boiling points of components like oxygen, nitrogen, argon, etc. Okay, so the principle which states that no two electrons in the same orbitals of an atom have same value for all four quantum number is the Aufbau's principle, On's rule, Pauli exclusion principle, dilution principle. So the right answer to this is actually Pauli exclusion principle. And the Pauli exclusion principle states that no two electrons in the same atom can have identical sets of quantum numbers. This governs electron arrangements in orbitals. Okay. All right. So the next one is how much of 5 gram of radioactive elements whose half-life is 50 days remains after 200 days. So 2.50 grams, 1.25 grams, 0.63 grams, 0.31 grams. So the answer here is 0.31 gram. How did we arrive at this how did we arrive at this particular answer? How did we arrive at it? All we did is the number of half-life equals to 200 divided by 50. So it is 4 because the say whose half-life is 50 days remains after 200 days. Okay. So it means that after each half-life, the substance is halved. So after one half-life, it moves from 5 grams to 2.5 grams. After the second half-life, it moved from what? From 2.5 to 1.25. After the third half-life, it moves from 1.25 to 0.625. Then after the fourth half-life cycle, it will move from 0.625 to 0.3125 grams. So approximately 0.31 grams. So that's the answer to that one. The next question says that the group 8 elements are the inert gas because they have lone pair of electrons on their valence shell, all have complete filled valence shell, which is actually the correct answer. I would have changed that out. Are all solids and are all polyatomic. So the correct answer there is B. And the reason is because groups 8, which is now group 18, element like helium, neon, and argon have full outer electron shell, making them chemically unreactive or inert. This is why they are also called noble gases. So when you have that equation there, the bond between Na and X is likely to be, is it covalent, dative, ionic, or metallic? The right answer to this one is actually ionic. And the reason is because the equation shows dissociation into ions, This indicates that the compound Ne2X contain ionic bonds between sodium, which is a metal, and X2 2 minus, which is a non metal. Okay. So the next one says the highest isotope of hydrogen is it deuterium, protium, tritium, or positron? So the highest isotope of hydrogen is actually tritium. That's option C. So based on this analysis, hydrogen has three isotopes. That's protium, which is one proton, deuterium, one proton and one neutron, and then tritium, which is one proton and then two neutron, highest mass number. Positron is a particle, not an isotope. So that nullifies that one completely. So the answer there is tritium, which is option C. When SO2 is passing to acidified KMNO4, the color changes from blue to green, pink to yellow, purple to colorless, or is it orange to green? So the answer to this one is there's a change in color from purple to colorless, and that's option C. And acidified potassium manganate is purple. When SO2 acts on it, which is a reducing agent, it reduces MnO4 minus, which is purple, to Mn2 plus, which is colorless. So the solution becomes colorless. Okay. The next one says that water gas obtained from the gasification of coke is made up of, is it nitrogen and carbon dioxide, nitrogen and hydrogen, hydrogen and carbon dioxide and carbon dioxide. So the answer to this one is hydrogen and carbon oxide. So water gas is produced by passing steam over hot coke. So when you have that reaction that way, so water gas contains carbon monoxide and an hydrogen gas. Okay. The next one says that sulfur 4 oxide can be used as is it as a coating agent, as a dehydrating agent, as a refrigerant, or as a drying agent? So sulfur 4 oxide is used as a drying agent. And the reason is because sulfur 4 oxide has a strong affinity for water, that is, it absorbs moisture, making it suitable as a drying agent, especially for gases. It is not a dehydration agent like concentrated H2SO4, nor a refrigerant. Okay. The molecular formula of hydrocarbon with an empirical formula of CH3 and a molar mass of 30 is, the right answer there is C2H6. And how did we arrive at this? If the empirical formula is CH3 and the molar mass is of CH3 is 12 from carbon, 3 multiplied by 1 from hydrogen, so that will be 15 gram per mole. Given the molar mass is equal to 30 gram per mole. So therefore, you say 30 divided by 15. That would give us 2. So the molecular formula will be 2 multiplied by CH3, which will be C2H6. Okay. The difference in molecular mass between an alkene and an alkyne with 6 carbon atom per mole is A10, B12, C2, D14. So the difference is actually C, which is 2. And alkene general formula CnH2n, which is C6H12. Alkyne general formula CnH2n minus 2. That is C6H10, and the difference equals to 12 for C6 is same. That's C6H12 minus C6H10, and that's just a difference about 2 hydrogen atom, which equals to what? To about 2 gram per mole. So that's the difference there. Okay. This was it from the table. Which of these two compounds can form functional group isomers? Is it S, which has R OR prime? Is it T RCOOH, carboxylic acid, or U RCOR prime, which is a ketone, and then V ROH, an alcohol, and W RCOOR prime? So is it option A, option B, option C, or option D? So when we consider it carefully, you discover that it should be option D, T, and V. And T, which is carboxylic acid, and V, alcohol, can be functional group isomers. For example, ethanoic acid, CH3COH, and methyl oxyl ethanol, same molecular formula, different functional groups, so they can be functional group isomers. Fats and oils are esters of fatty organic acid. combined with a trihydric alkanol, commonly referred to as A, ethanol, B, butanol, C, glycol, D, glycerol. And the answer to this is D, glycerol. It's like 1, 2, 3, try, it's a fat and oil equals to esters of fatty acid and glycerol, a triol with three hydroxide group. So glycerol is what? C3H5OH3. Hence, fat and oils equals to triesters of glycerol. Okay. Determine the half-life of a first-order reaction with rate constant of 4.5 times 10 to the power minus 3 per second. Is it A, 154 seconds? Is it B, 15.4 seconds? Is it C, 1,540 seconds, or D, 1.54 seconds? So when we solve this right, we will end up having 1.54 seconds. And how did we arrive at this? The formula for half-life of first-order reaction is T half equals to 0.693 divided by K, which is the decay constant. So your T half, which is the half-life, will be equals to 0.693 divided by 4.5 times 10 to the power minus 3. So when you solve and you punch the calculator right, you end up having 1.54 seconds. Alkaloids are naturally found in A, lipids, B, vitamins, C, proteins, D, rubber. So alkaloids are naturally found in A, lipids, and alkaloids, also referred to or also known as esters, are organic compounds formed by the reaction between carboxylic acids and alcohol. In nature, they occur in fats and oils, and which are esters of glycerol, a triol, and fatty acid. These esters are major components of lipids. CH3, CH2OH, and CH3OCH3. The relationship between the two compounds above is that they are allotropes. B, they are isotopes. C, they are isomers. D, they are isobars. The right option here is that is C, they are isomers. So CH3, CH2OH is ethanol, and C3O, C3 is dimethyl ether, which is an ether. So they have the same molecular formula, but different structures and functional groups, making them functional group isomers. Okay. The composition of the alloy, permalloy, is iron and A, copper, iron and B, nickel, C, iron and C, lead, and D, iron and D, magnesium. So the right answer is nickel. So it's a composition of iron and nickel. So permalloy is an alloy composed of 80% nickel and 20% iron. It is widely used in electronics due to its high magnetic permeability. It is not a common structural material, but rather a magnetic alloy. Okay, so an aqueous solution of sodium hydroxide can be used to test for the presence of, is it iron 2, zinc 2, or copper 2? So looking at the options that we have there, you discover that an aqueous solution of sodium hydroxide can be used to test for option C, which is 1, 2, 3. We can use it to test for for calcium, zinc, that's zinc 2, and then for copper also. So sodium hydroxide will react with calcium ion to form white precipitate of calcium hydroxide. It will react with zinc 2 to form white precipitate of soluble, that is white precipitate that is soluble in essence sodium hydroxide, and this is because it is amphoteric. When it reacts with copper, on the other hand, it will form blue precipitate of copper hydroxide. Therefore, it is used to detect all three cations. The IUPAC nomenclature of the compounds. Okay, I was supposed to put an image to this. Okay, so pardon me, please. Okay, sorry. The answer anyway is 2-methyl propane 2-hol. I don't know why I forgot to put the email. So please pardon that. And the reason is because the compound is likely has its this structure. C3 3COH, C3 3COH, and so this structure contains 4 carbon atoms, hence butane, 4 methyl branch at carbon 2, and the OH group also attached at carbon 2. Hence, IUPAC name is 2-methyl propan 2 or 2-methyl propan 2 all. All right. Thank you very much for joining me in solving 2024 past question. And that brings us to the end of this past questions series. I hope you've learned a lot in the course of interaction, as in looking at the past question from 2014 up until 2024. So I wish you all the best, and I hope to see you in great places. Take care and bye for now.